Okay, so this is lesson 11.4, volumes of prisms and cylinders. Our objectives, students would be able to find the volume of a prism and the volume of a cylinder. And I'm going to tell you, here it is. This is the best shortcut I can have. You find your area of your base, your big B. You multiply it by height, and you're going to have volume. And that is the goal. Base identification, know what the formula is, and you're off to the races. So, volume is the space that a figure occupies. It is measured in cubic units. So the volume V of a cube, okay, the volume V of a cube of the length of its edge, or V equals E cubed. Okay, so if I'm talking about a cube, okay, and that's E, so the volume is E cubed. Now, essential understanding. You can find the volume of a prism or a cylinder when you know its height and the area of the space. Volume is equal to base area times height. Gosh, where have we seen that before? Probably right on the front page. Both stacks of paper below contain the same number of sheets. In this particular case, we're looking at sheets that have been pushed aside and sheets that are all nice and perpendicular with the base. I got to ask a question. Did I take a sheet away? I just slid it to the side. It still has the same volume of paper in those two shapes. The first stack forms an oblique prism. The second forms a right prism. The stacks have the same height. The area of every cross section parallel to a base is the area of one sheet of paper. The stacks have the same volume. These stacks illustrate the following principle, which is called Cavalier's principle. If two space figures have the same height and the same cross-sectional area every level, then they have the same volume. Let's make that they have the same volume. Now, the area of each shaded cross-section below is 6 centimeters squared. Since the prisms have the same height, their volumes must be the same by Cavalier's principle. Now, keeping in mind, we're talking about cross-sectional area here. These cross-sectional areas, all of them, are the same. They're all 6 centimeters squared. And because the heights, h, in each case is the same, their volumes will be the same because the cross-sectional area is the same at every level all the way through. You can find the volume of a right prism by multiplying the area of the base by the height. So volume is base area times height. Okay, and if I have my base area in these cases are 6 and I multiply by whatever height they all are at, their volumes should be the same. Okay. Now, the volume theorem of a prism, area of base times height. You identify your base, identify base. Find its area, big B has been found, multiply by height, and then you have the volume. So it's as simple as 1, 2, 3. 1, find your base. Okay, volume is equal to my area of my base times height. My area of my base is a rectangle. Base times height, okay, BH, okay, 24 times 20. Let's just do that. 24 times 20 in this way, because that's BH, 24 times 20. That's the area of my base area, times my height. My height is 10. And now I'm sitting here, I'm looking at 24 times 200, and I'm talking about 4,800. Now that's crazy, right? Centimeters cubed. It's as fast as you identifying the base. Here it is, my base. Find its area. Therefore, after you find the base area, that's big B, you have volume because you just multiply it by height. Okay, now volume is equal to base area times height. My base is 5 times 3. My height is 4. And now I'm sitting at 60 feet cubed. 60 feet cubed. It's your turn. Turn me off and do the third one. Remember, area of base times height, you got volume. Okay, welcome back. Volume is equal to area of base. My base area, 6 times 3 is 18. My height is 3. It's 54 feet cubed. Okay, that's it. 1, 2, 3. 1, base, identify your base. 2, find the base area. 3, multiply that by height, you got volume. Now, let's see if we have different things. Above, if a different side of the rectangle prism were used as the base, does the volume change? If the different side was used as base. If a different side was used as base, that's going to be 9 times 6. Boy, 9 times 6 is going to be way different than, oh, no, it's not. Of a different side. This is 4 times 3, that's 12. Well, 12 times 5 is way different than, oh, no, it's not. It's going to be the same. Well, this one's going to be way different, because this is going to be 10 times 20, which is 200. 200 times 24, uh-oh. That's going to be 4,800 too. That's the same as 200 times 24. So as long as I'm talking about rectangular prisms, or what they say is parallel pipedids, okay, in rectangular prisms, we have 3 choices for the base. Area to find our volume. That's crazy, but that only works in rectangular prisms. The other prisms are very specific. You must find that area of the base. The reason they work up on top so easily is because those rectangular prisms are consistent all the way across with them. So let's talk about these guys. Okay, when I'm looking at these prisms, these are triangular prisms. And in triangular prisms, you've got to use the triangles as your base. Otherwise, we're going to be lost. So these are our base. Okay, these are our base. So keep that in mind. And I've got an equilateral triangle for my base. So if this is 4, this is 4 to the square root of 3. Now I want to be clear what I did there. When I cut that triangle, I've got a 30, 60, 90. That's a 30, 60, 90. This is x, this is 2x, this is x to the square root of 3. And that's all I did. This is 4 times the square root of 3. That's it. Okay? That's a 30, 60, 90 triangle. And then after I do that, I can totally use that in area of a triangle, which my big B is, 1/2. My base is 8. My height is 4 to the square root of 3. And that's where I'm going for one triangle. Okay, so let's extend that page. And I got volume is equal to the area of my base times my height. Well, I just found the area of my base. 1/2, 8 times 4 to the square root of 3. Okay, that's my base area. Times my height. My height is the separation of my bases, 10 inches. So now I'm looking at that, and I'm grabbing for my calculator. I got half of 8, which is 4, so I got 16 to the square root of 3. 16 times the square root of 3 times 10. And I come up with 277.13 inches squared. Cubed, excuse me. Volume is cubed. Volume is cubed. And finding the volume of a triangular prism, what is the volume of a triangular prism? That's where I'm looking at. It doesn't say what to round to. I'm going to round to the 100th unless it's otherwise stated. Now here's the thing. In this one, my triangle was an equilateral triangle. I had to find things. I had to find my height, and I used the base of 8 length to find that area of my equilateral triangle. Over here, I don't have an equilateral triangle. I have a regular old triangle that has a perpendicular sides on it. And remember, they're consistent all the way through. And I have a base and a height. So it's your turn. You're still doing volume equals big B times H, and you determine big B, and big B is something. Go, turn me off and find it. Okay, welcome back. You got your base is 1/2 base times height. And your base and height are perpendicular to each other, 6 times 10. And that's half of 60, which is 30. So now I know that's 30 times h, and my h, and remember, my h is this distance here, that distance. So how far are these two bases apart? Oh, they're 5 apart. So this is 150 meters cubed. Remember, volume is cubed, area is squared. Theorem 11.7, volume of a cylinder. The volume of a cylinder is the product of the area of the base and the height of the cylinder. Well, that's crazy. But you got to keep in mind, area of a base in the cylinder, anything circular, that big B is pi r squared. So really, this can be pi r squared h. Okay, the area of a cylinder, of the volume of a cylinder, has that area of the base, pi r squared, times the height. Area of the base, pi r squared times height. Well, gosh, whiz bangerangs. Big B is pi r squared. So volume's still big B times h, but big B is pi r squared h. So now, I've got r, I got h, so pi 3 squared 8 times 8 is 9 times 8 is 72 pi. And they wanted this to in terms of pi, so I got 72 pi centimeters cubed. Now, you know what's really cool, what's outstandingly awesome about volume? The volume of an oblique shape. Okay, like this oblique cylinder. This is an oblique cylinder. The volume, so the volume on this is still area of base times height, and it's the area of base. Gosh, you know that base area looks awfully circular. Pi r squared h. Well, r, well, this is actually d, so r is 1. So pi 1 squared times h, which is 3. So this becomes 3 pi meters cubed. So that's my volume there. And here's my volume over here. So we're getting these things rolling. Now, a composite space figure is a three-dimensional figure that has a combination of 2 or more simpler figures. You can find the volume of a composite space figure by adding the volumes of figures that are combined. And I'm saying right now that your focus is area of base. You find that base area, then multiply by height. And guess what? That's volume. So always focus on that area of the base. That's our theme. Now, we're supposed to find the volume of the composite figures. And if I'm doing this, I've got a base area. My base area. Okay? How do I prove it's a base area? It's consistent all the way through the figure. Okay? Now, there are some tricks on these things. That's why I put it in there. I have this coming across here. This is a half circle. And people, how do you know it's a half circle? Half of 24 is 12. That's a 12 is equal to radius of half a circle. Okay, that's what I noticed. Now, this is 24 here. This is also, so this is 12 going down here. Okay, they say that whole thing is 48. So this side is 36. Okay, so this side is 36. We're going to get a different color. Maybe green. Well, no, green does not show up better. Okay, but we're going to talk about how I know it's 36. So this is 36. Now, folks are like, whoa, boom, stop the presses. I know that this is 24, so that makes this 12. So 12 in already. So I'm 12 in of 48. That's 36 left at this point. That's 36. So this part has to be 36 long. This is 24. That's 36. Okay? And The blue is my half circle. Now it's 24 high for my volume, but my base area is got some stuff going on. I'm going to put this back up here. Okay, I know that that's 36, and I know that this is 12 here, and that's how I know. Okay, so now with those things, with the information I have provided, and I've kind of working on the ideas, volume is equal to base times height. Let's work on our base. My base is going to be 24 times 36 plus my half circle, half of pi r squared. And my r is 12 squared. That's my base. My height, remember, that's this base. That's the 24 by 36. This is my half circle. Okay. Now my height is going to be blue here at 24 inches. 24. That's my height. Now after I get that 24 times 36 plus 1/2 pi 12 squared in my calculator, I multiply it. Oh, I got to get that pi in there. Okay, let me do this. My calculator is not working well. I've got 24 times 36 plus 0.5 times pi times 12 squared. Okay, and that's going to be 1090 half pi 12 squared 2436 times 24. And it's going to be 26,164. And that's 6.7 inches cubed. Okay. Now, this next one is done in a similar fashion. I just want to make sure that you realize that. It's not like they're different. We're still going to find the area of the base and then multiply by height. Okay. Now, keeping in mind, I've got a base that's 6 by 6. So volume is equal to area of base times height. Well, I got a 6 by 6. 6 times 6 is one part of my base. Okay. Times, or excuse me, not times, but plus. So that's the 6 by 6. That's my square. Plus my half circle. My half pi 3 squared. Now that is the other part. And I suppose that half pi 3 squared, let's make that blue so you can see that. That's this part. That's this part. Okay. Now, this whole shape, excuse me, this whole shape, when we're doing this, if we group that together, passes all the way through. That's why we take the area of our base times height. Okay, times height. My height is 10. And that's going to give me my volume. So I've got 36 plus half of 9 pi times 10. So I have 501.37 inches cubed. Now, I've got to ask, here it is, it's your turn. Can you find the volume of the last piece? Okay, there's a theme that I've been trying to work on. It's your turn. Have at it. Go. Okay, now remember, you're supposed to turn me off to do that, so turn me off and go. All right, so welcome back. Remember, area of my base that's consistent on this is this thing. Okay, that's my consistent base. It's right here. It's going to be the same deal going all the way through. That's assuming that, you know, I have a good base. Let's make it better. So I'm looking at this coming along, coming around like that. Okay, and then that passes through all the way. So once I get the area of the base, I multiply by the separation of the two bases, or the height, and I get volume. Okay, but let's focus on our base area. First of all, this is 12 high. That means I got a radius of 6. That means if this is 6, here, the way that sits, that's looking like it's 8, not 18, but 24. On that one, on this one up top, on this one up here, it was 48, and I subtracted 12 to get 36. But this one down here, they're asking me, telling me that this area is actually 12 by 24. So if they've got a 12 by 24 area, okay, plus now my half circle. Remember, I'm doing my rectangle plus my half circle. And my half circle is extra, so it's 1/2 of 6 squared pi, because 6 is my radius, and I can know that because of half of 12. Okay, so now I've got this as my base, and then I'm going to multiply it by my height of 10. So that's my volume. So now I've got 12 times 24 plus 0.5 times 36 pi. Yep. And that's 344.54 times 10. So it's 3445.49, and that is inches cubed. Now, this whole time I've been doing area of base times height, area of base times height. I mean, that's really been the theme. What if I saw this as prism plus, somehow I'm going to get this half thing in here. I'm just going to put it in the right orientation. My half cylinder. Okay, so if I do prism, which in this case is 12 times 24 times 10, plus half cylinder, 6 squared pi times 10, okay, well, I have the same answer. So I'm looking at 12 times 24 times 10. That's going to be giving me 2880 plus 0.5 times 36 times pi times 10. And that's going to give me 565.49. And I add those together. And after adding those together, the volume becomes, drum roll, 3445.49 inches cubed. Completely different than the way I just did it. And remember, the only difference is I would have distributed the 10 out, and that's where these numbers came from all. Okay? So keeping in mind, area of base times the separation of the two bases, area of base times height, always volume. Okay. The summary, objective, students will be able to find the volume of a prism and volume of a cylinder. Write a couple of sentences about something that you learned today about the learning objective, then rate yourself on a scale of 0 to 4. Thank you for your time today, folks. Have a super day.